Alrighty, happy Monday, everyone. We have reached the end of our trigonometry unit, and in the past week and a half, 2 weeks, we've been talking about how to work with the trigonometry of non-right triangles, and you learned about the law of sine, and you learned about the law of cosine, and you learned about finding area of some, or I guess in a unique way with a unique formula. And so pretty much our last little chunk is just taking word problems or descriptions of scenarios and applying those laws to these scenarios. So I'm going to be doing a couple of videos on a few scenarios just to walk you through the types that you should be expected to do. And then when this comes time for your quiz, you'll be exposed to similar scenarios. So let me go ahead and read it real quick. So it says, 2 ranger stations located 10 meters apart on the southwest and southeast corners of a national park. They receive a distress call from a camper. So let me go ahead and draw that out real quick. So I'm just gonna, let me see if I can. So it said there was a park. So I'm just gonna, so let's just pretend that's my park. And then it said the southwest and southeast corner. So this in my drawing would be the southwest corner. This over here would be the southeast corner. And then it also mentioned that there was a camper. So there's a camper that's stuck or a camper that's stranded somewhere. So let's just go ahead and say my camper is here. So camper. Okay, so the camper is asking for help. So it says electronic equipment allows the Southwest Ranger to determine that the camper is at a location that makes an angle of 61 degrees with the boundary. So that's telling me that from here to, so that's telling me from here, how does it keep doing that? So that's telling me from here to the camper, this angle stuck in here, so this angle right here is 61 degrees. And if we keep reading, it says another beacon. So the Southeast Ranger sees that the camper is 9.2 kilometers northwest of his position. So that would be northwest. So obviously that would be the change from the Southeast Ranger. And it says that the camper is 9.2 kilometers away. Oh, and at the beginning it also told us that the 2 rangers were 10 kilometers away. Okay, so what's the question? So that's pretty much our scenario. Now it says, which station is closer to the camper and what is the difference in those distances? So, okay, if I already know the distance from the Southeast Ranger to the camper is 9.2, but I do not know what the distance from the Southwest Ranger to the camper is. So that's definitely going to be one of my variables. Now, in deciding, so remember we had a little mini lecture about how to choose between the law of sine and law of cosine. So we just have to be like critical thinkers. In this scenario, I noticed that I have more sides than angles, which normally would lead you to the cosine law. And you are free to use the cosine law, except you're going to run into a scenario that seems really weird. So I don't know if you remember, but I also told you that in the case of SSA, which is this case right here, where we have a side, another side, and an angle, so that's SSA, that it could kind of go both ways. So this is one of the scenarios where you could use the law of cosine, but I don't know if you, like there's a point where you'll reach and the solution is going to seem weird. So I'm actually going to recommend on this one that we try a sine law. And I'm going to recommend that for this sine law, we find this angle right here. Okay, so why take this approach? Well, I know that if I find this angle, so I'm going to call this I guess, y. Then if I know two of the angles, I could find this one very easily. And then if I know that one, that would lead me to that angle. So I'm just being a little strategic. Okay, so according to the sine law, it would be sine of 61 over 9.2 is equal to sine of this magical angle that I do not know yet over 10. So again, I used the sine law, and the way I set it up was I knew this angle and it goes over this side, and I want to know this angle and I put it over this side. So I just went across from each other. Okay, so let's cross multiply. So I can multiply these two together. I can also multiply these two together, and that would give me 10 sine 61 is equal to 9.2 sine y. Okay, so I know that my goal is to get the variable alone, so that's the piece that has the variable. So I'm going to have to get rid of this 9.2, and if I do the math, let's see. So this is going to become, let me change the size real quick. So this is going to become one of those ones that I always draw. So I'm going to cheat real quick. Let me see, number one. I already reworked them all out. So it looks like it's 0.9507. So if I work it all out, I get 0.9507 is equal to sine y. And then again, if our goal is to get the y variable alone, we have to get rid of sine. And you should be familiar with this thing called sine inverse. Sine inverse. So pretty much this means we can find angle y by doing sine inverse of 0.9507, which I'm going to cheat again real quick, ends up being 71.93. 71.93 degrees. Okay, so now I know this angle. 71.93 degrees. And then hopefully you know that in a triangle, the maximum number of degrees you can have is 180. So I currently have a triangle that has 61 plus 71.93, and that's going to give me 132.93. And if I do 180 minus 132.93, I will end up with 47.07 degrees. So that's going to be this angle right here. Okay. And now that I know pretty much all the angles and two of the sides, and I'm just trying to find this last missing side right here, I have options. I could use the law of sines again, or I could even use the law of cosines in this case. It really doesn't matter. So I'm going to, since I already kind of used the law of cosines on one, the law of sines on one, I'm going to use the cosine law this time. Okay, remember that in order to choose which letter we start with, we figure out what do we want to know. So if I want to know this side, then I'm going to have to reference this angle. So I'm going to start with x squared is equal to 10 squared plus 9.2 squared minus 2 times 10 times 9.2 cosine of 47.07. And if I put all of that in the calculator, let me go to a Desmos window real quick. Let me see. Dang it, I don't have Desmos up. Where's Desmos? Right here. So I'm going to do 10 squared plus, I already forgot what it was. 10 squared plus 9.2 squared. 9.2 squared minus 2 times 10 times 9.2 cosine of 47.07. And let me make sure that it is in degrees. So 59.317. So 59.317. And obviously I need to get rid of this square. So I'm going to take the square root. And if I do that, I will get approximately square root of 59.3168.025. So it looks like 7.7. So 7.7 kilometers. So that means that the first camp, the southwest camp, is about 7.7 kilometers from the camper. So obviously it's a little closer to the camper than this one, than the right side, because this one is 9.2. So that was question A. Which station is closer to the camper? The southwest camp is closer. And what's the difference? Well, we could do a quick 9.2 kilometers minus 7.7 kilometers. And that leaves us with 1.5 kilometers. So the difference is 1.5 kilometers.